Geometry Chapter 11, Review, Part B. So we're looking at sections 11:4 through 11:7 right now. This is just review work that's out of your book. I think it starts on page about 810 or so. This is probably at about 812. Alright, so looking at this first thing, we didn't exactly do this in order. We kind of did a little bit of each one each day. So we have kind of different things that we're looking at, but as we review, this is how you can use your textbook to help you look up these topics as well. So the first major topic is inscribed angles. Remember, an inscribed angle, just remember that it looks like a Pac-Man, kind of like a Pac-Man, but even more like a Pac-Man where it's split all the way across. In other words, this line goes all the way there and all the way there. So if I have a line that's more like this, where this piece right here does not touch the edge, then that is not an inscribed angle. Alright, so the big idea with inscribed angles, whatever this is, let's call this the arc and this the angle. The arc divided by 2 equals the angle. So when you have complex pictures, you just got to piece together what things match the arc. So if you notice, the first question up here says find the measure of angle ABD. So that's this angle here. Let's color code this. How about red? Red and red. Well, that red angle matches this red arc, and that red arc is 108. So that's why they did 1/2 of that and got 54. Similarly, let's do the other one in blue. This angle is 28 degrees, so then it's asking about this arc between B and E. The measure of arc between B and E is going to be double that angle. That's how we get 56. So that's kind of interesting that this angle and this arc are pretty close in measure. But there's different ways to get them. Sometimes you double, sometimes you have it. It depends on which piece you have and which piece you're trying to find. So let's take a look at the next piece here. Let's do some exercises. So first thing it asks us is measure of JL. JL. So that's the arc from here all the way to there. That's going to match this angle here, which is 82 degrees. So measure of arc JL divided by 2 is going to equal angle, measure of angle, what is this, JNL. Well then, if I want to figure that out, let's see what we have. Measure of arc JL divided by 2 equals 82 degrees, and I want to get JL. Well, I'm going to multiply both sides by 2, and I get 164 degrees equals the measure of arc JL. So these two 2's reduce down to just 1. The next one, pretty similar. It's just asking us for the other piece. We're looking at the angle, so it's saying, what's this angle here? MKL. MKL. So we're looking for this angle given this arc. So MKL, that arc, we know that arc ML divided by 2 is going to, half the arc equals the angle equals measure of angle MKL. So that's what we're trying to figure out here. We know that this arc is 64 degrees, so 64 degrees divided by 2 equals the measure of angle MKL. And then 64 divided by 2 simplifies to just 32. These are so easy. As long as you remember that the arc divided by 2 equals the angle of an inscribed angle. Meaning that we're looking for the angle and it's on the circle. On the circle. That's the key. Otherwise, we can't really use this property. Next, find each value, x. Oh, that's easy enough. So if we look at this line, I know something special about this line. It passes through the middle. And that makes it a chord that goes exactly through the middle, or in other words, a diameter. Which also means that this is a semicircle. And if that's a semicircle, let's make my pen a little bit bigger here. This is a semicircle from C to A. It means that that's going to be 180 degrees. If that's 180 degrees, then this arc is going to be divided by 2 to find this angle down here, ABC. So measure of angle ABC is equal to the arc AC, let's say, divided by 2. Well, we know that's 180 divided by 2 equals this angle, and that's actually 3x plus 12 based on that equation. 180 divided by 2 is going to be 90. That equals 3x plus 12. Oops, pardon. 3x plus 12. And if we solve this, we subtract 12, then we get 78 equals 3x. Divide by 3, divide by 3. 3 goes into 78. Ooh, a lot of times. Let's see this. I don't want to screw it up here, so let's use trusty old long division. It goes into 7 twice, and 18 6 times. So x equals 26. Are we done? Yes, we are, because all it asks us to do is find x. All right, let's use a different color here. How about green? There we go. Green. We're finding measure of angle RSP. RSP. This is kind of interesting because this angle and this angle have something in common. They have this arc in common. So if I know that arc PR divided by 2 equals 3y plus 3, which is RSP, angle, measure of angle RSP. I also know that PR, the arc, divided by 2 is equal to this angle here, which is 5y minus 21. You see that they're both equal to the same thing. When two things are both equal to each other, I can do a little bit of substitution and then set these two pieces equal to each other. So that means 3y plus 3 is equal to 5y minus 21. If I do a bunch of algebra here, subtract 3y from each side, add 21 to each side, we got 24 equals 2y. Divide by 2 on each side. What's y going to equal? 12 equals y. Now that's interesting because we're not done. Why not? Because it said measure of angle RSP. We have to figure out what this actual measure is. We know that y equals 12. So 3 times 12 plus 3 should give us this angle. 3y plus 3. So that's going to be 36 plus 3. That's 39 degrees. There we go. Remember, if any time, if you need to, just pause the video, go back. That's the reason it's on a video, so you can play it at your pace. All right, now as we're looking at this one, we're still dealing with inscribed angles. So it's kind of interesting because it looks like the angles are different than the inscribed angles, but this angle still has the same measure. Why? Because the vertex is on the circle. Same with this one. So it says find UWX, UWX, this angle over here. Well, if we know that this arc is 60 degrees, and we know that the arc divided by 2 equals the angle, then it's going to be 160 divided by 2 equals measure of angle UWX. So 80 equals measure of angle UWX. It was that easy. Super easy. They did it for us too, but I just want to show you how they got it. It says find measure of arc MR. MR is going to be this arc here. Now this arc comes from this angle, which is 41 degrees. And we know that the arc divided by 2 is the angle if our vertex is on the circle, because we're looking at inscribed angles. So that arc divided by 2 is going to be 41 degrees. Got to get rid of this 2 in order to solve for just the arc. So we have that the arc is going to be 82 degrees. So the measure of arc MR is 82 degrees. The next thing that we look at here is measure of angle QMR. QMR. Well, in order to know this angle, we need to know the arc that's across from it. And in order to know that arc, I need to know how the three arcs work together. Well, we know that this arc, MR, was 82 degrees, and this one here, MQ, is 120. And if I go from MQ, which is 120, and then MR on this side is 82, then this final piece that's left on the end, QR, that has to make it a total of 360. So 120 plus 82 plus arc QR, the measure of this arc, is going to equal 360. Now I can do some simplifying. This gives me 202 plus measure of QR equals 360, and then as I subtract 202 from both sides, this side is going to be a 0, and then measure of arc QR is equal to, well, let's see what we get. 360 minus 202, that's the same thing as like saying 358 minus 200. Well, that would be 158. 158 degrees for the arc. But that's not the question. The question is, what's the angle? The angle is equal to that divided by 2. So measure of QR divided by 2 equals measure of angle QMR. So in this case, it's going to be 158 divided by 2 equals the angle QMR, which is, what would that be? 75 plus 4, 79 degrees. So this equals 79 degrees. Let's keep moving here. Okay, so now we have some other angles. Notice that the vertex this time is inside the circle. It's not on the circle. And when you're inside, it's going to be the sum of the two arcs. So it's the arc 1 plus the other arc, let's say arc 2. We're going to divide it by 2. Another way of thinking that is it's kind of like the average. So this equals our angle, the measure of the angle. So for this first one, what they did is they took half, or divided it by 2, and they added the two arcs. They did 31 plus 87 is 118. Half of that, they got 59. So I'm going to do the same thing here. 41 plus 93, that's my two arcs, divided by 2, and that equals my angle in the middle, GKH. So if I add those two together, 41 plus 93 is going to give me 134. So then when I divide this by 2, 2 goes into 1365 times plus another 2 into that. 4 is 130, pardon me, 65 times plus the 4 is another 2. So that's 67 equals 67 degrees equals measure of angle GKH. Next. Ooh, we got some application going on here. A piece of string art is made by placing 16 evenly spaced nails around the circumference of a circle. A piece of string is wound from A to B and C to D. What's the measure of BXC? Right here, BXC. Well, in order to know that, we need to know this arc and this arc. I noticed that there's 16 of them. So if I figured out one little piece, then I got 1, 2, 3, 4, 5, 6 of them here and 2 of them there. That could tell me how much, or how I could find this middle angle. Well, if I know that there's 16, and that goes into 360, how many times? Well, why would I care? Because they're evenly spaced, so I can figure out how much each one is by dividing 16 into it. 16 goes into 36 twice, and then when we simplify this here, 16 goes into 40 again twice, and then that'll be 32. We'll have 8 left over, and 16 goes into 80 5 times. So about 22.5, actually exactly 22.5. So each one of these is equal to 22.5 degrees. So that means I got 1, 2, 3, 4, 5, 6. 6 times 22.5 on this side, and over here I got 2 times 22.5. Well, that would be 45 on that side. And on this side it's going to be 90 plus 45, or 135. I'm going to add those two together and then divide by 2, because when we have it inside, when we have a vertex inside of an angle that we're trying to find, it's one arc plus the other arc divided by 2 equals the angle. Okay, so the two arcs in this case are 45 and 135, pardon me, divided by 2. That's going to be our angle. So if we're to simplify it just a little bit more, 45 plus 135 is going to be 180. So 180 divided by 2 equals our angle. Wow, that's kind of interesting. It actually equals 90 degrees. It's that angle. 11-6, we only got a couple more spots here to fill. This one is now we're looking at segment relationships, not angles, but segment. And we're going to also be looking at where are the lines, or the line segments. Are they inside the circle like this one? Are they going to be on the circle or outside the circle? How are we going to figure that out? Okay, so let's start with this one. Let's just jump right into it. The general idea with any type of segments is you're going to be multiplying some type of piece. Let's put it on this side just for space's sake. Like this together. And we got to figure out what these two pieces are going to be. So if we look at one line, this is one piece, so the first piece times piece equals the other piece times piece. And where do we get these pieces from? Well, from a line here. So BA and AC would be one of them. BA times AC. The other one would be DA and AE. So I got to split that line into two pieces. Well, DA is 7. AE is 5. And we got 3 and Y on the other side. So this is 3 for BA, and this is just Y. So in other words, 3Y equals 35. And we divide both sides by 3. Y equals 35 over 3. On these type of calculations, you get a lot of fractions because there's so much multiplying different parts together and then dividing in the end to get something by itself. So that would be your answer for this piece for Y. Let's look at the other one over here. Again, it's going to have that same setup. Something times something equals something times something. So we have the two pieces. So for the left side, let's do 15 and 8. For the other side, we got 10 and Z. 10 and Z. So 10Z equals 15 times 8. 15 times 8 is the same as 4 times 6 here, 240 equals 10Z. We divide both sides by 10, and 24 equals Z. Now this next example is a little bit different. Notice it has FG and FJ and AFG. So that's the whole thing times this piece. And the other one's FK and FH. So it's the whole thing times this piece. So now we still have that same setup. Two pieces multiplied on one side and two pieces multiplied on the other. So let's look at the left side first. So we got 4 for FG. And then the whole thing is 4 plus 12. And that's where they get this 16 from. Then the other side we have 6 and then 6 plus x. They're getting that 6 plus x because it's the whole piece. So that's where they're getting those numbers from. Let's see if we can replicate it. So here we got to do the piece and the whole. Those are the two things that we're going to be multiplying there. So that'd be, the piece is just 6, but the whole thing is 6 plus 4. And then the other side we got 5 on the outside, but then the whole piece is 5 plus x. So 6 plus 4, that's 10 times 6. And then over here we have 5 times 5 plus x. What you'll probably wind up doing is distributing here. You don't have to all the time, but you might. It's just something you could do. So we have 25 plus 5x. And over here we have 60. Now as we work this out, we subtract 25 from both sides. and we get 35 equals 5x. Divide by 5 on both sides. X equals 7. Check. At all. Over here on this one, we got 4 and y and 5 and 5. So let's not get confused with these 5 and 5s. Remember, you're always going to start with 2 pieces multiplied equals 2 pieces multiplied. But these 2 pieces, we got a short and then a long one, and a short and a long piece. So let's do the short one here. How about 4, and then in the long piece it'd be 4 and the y put together. And for the other one it's 5. But then the long is going to be 5 plus 5, both pieces added together. So that means we have 5 times 10 on the right side. On the left side we have 4 times 4 plus 1. So again, I'm going to distribute this just to kind of open that parentheses up, kind of get inside so I can move some things around. This is going to give me 16 plus 4y equals 50. If I subtract 16 from both sides, sorry for that interruption. Trying to do videos at lunch. Everybody's always making announcements. Okay, so then we have 4y on the left side, and on the right side we have 50 minus 16, which is going to give me 34, I believe. Divide both sides by 4, then we got y equals 34 over 4. Now most likely on a multiple choice test this would be reduced. On a free response question, no need to. But if it's a multiple choice test and we had to reduce it, we'd reduce 34 to 17 and this to 2. But they're both equal. Both answers are right. One's just simplified. Next. Okay, we're at the final stage here. The last section that's going to be on this Chapter 11 Part B test is 11-7. So if you look at the graph, it says x minus 2 squared plus y plus 1 squared equals 4. Let's look at the numbers and see where they come from. First of all, this has to do with the radius. But if you know the radius is not 4, it's actually 2. So this is really 2 squared. That's where they get the radius from. It's 2, this is squared. And then these two terms are squared as well, but they're shifted. This -2 and this +1 shows how that the graph gets moved away from the center. Not at 0, 0, but it moves away. But notice that if it's centered at 2, -1, and this is -2, +1, that this equation of the graph is almost opposite of what happens here. It's like you subtract it. So in general, if you think of the center as like a H, comma, K, why am I using those letters? Well, I don't want to use X and Y. Anytime you talk about the center of a graph, it usually uses the letters H and K. So then this is going to be X minus H squared plus Y minus K squared equals, and then our radius squared. Something to notice though, you guys, this can be written all kinds of different ways. It could be Y minus K squared plus X minus H squared equals R squared. Or it could be R squared on the left side, and then X plus H, or not X plus H, pardon me, X minus H squared plus Y minus K squared. It can look like any of these. They're all the same thing. It's just doing some algebra to move stuff around on one side or the other. Let's try an example. So we look at this one. We have 2 examples here, by the way. One on the right is visual, the one left is algebraic. We've got to do it by working out the pieces. So we have an H at -4, a K at -3, and R equals 3. So we've got to fill this in. We know we have something squared, and then something else squared, and we got an R squared over here. Well, let's do the Y's first, just to be different, to keep our brains a little fresh. So this is -3, so I know inside here this is going to be Y plus 3. It's opposite, because it was Y minus K. This is X minus H. So this is going to be X plus 4. We're going to add those 2 pieces together. Then on the right, the radius is 3. So that means this is 3 squared. So if this were simplified, it would say Y plus 3 quantity squared plus X plus 4 quantity squared equals 3 squared is 9. So in a multiple choice exam, you would see that on a FRQ or a free response question. You wouldn't necessarily have to do it. Unless it says simplify, of course, but how often does it say that? All right, for the right side, notice that our center right here is at 1, -1, So my h is 1, my k is negative 1. So let's do the x's first this time, then the y's second, and then we have our radius. So it's going to be x minus 1, because this is positive 1 up here, so it's negative 1 down there, and then y plus 1. Then for this last piece here, the radius is how far it is from center to the edge of the circle, which is 4, so this is 4 squared. Now if I had to simplify, I would have written 16, for example, if it were a multiple choice test. I think that's it. After this, it goes into other things. Oh, we got a graph. Let's graph something real quick. Last one here. So first I need to figure out where my center is. My center, it seems like, is opposite this, so h equals negative 2 and k equals 2. So that means I gotta go 1, 2 in the negative direction, and then up 2 in the positive direction, so we're here. And then I see this radius is 1. Now that's kind of interesting because 1 squared actually equals 1. So the radius is 1, and 1 r squared, the radius squared, is also 1. So it means I gotta go a little tiny circle. Little tiny circle. There we go. That's it. Done. Watch the video again if you need to. I'm also going to be posting a video about using the Ready to Go On quiz as a bunch of examples to work out.